students. Now I am going to explain about interfacing a simple toggle switch to 8051, and we are going to see the programming part also, how to generate an interrupt which switches on a LED continuously as long as switch is on. Now for that I have drawn a picture here, or a block diagram I am representing now to understand this problem statement. What is that? Let's look into the concept. Say this is your microcontroller CPU, IC microcontroller 8051, and where a toggle switch is connected to the interrupt, external interrupt, say INT0, which is connected already now here, and one of the LED is also connected to the port 1 of second pin. So this is shown over here because the statement says that I have to interface toggle switch as well as a LED should be glown when the toggle switch is pressed. So now since I am connecting a toggle switch to the INT0, which is one of the external interrupt. So how it works, when the moment I press the switch, how the microcontroller will receive it as an input, and what type of behavior we expect to exhibit from the microcontroller. That is well depicted in the this flow diagram. What is this? Look at here. Assume that some microcontroller is executing some main program. The moment when I press a toggle switch, that means I am generating an interrupt here. External interrupt is generated. The main program will be halted, for your information, and it branches to the vector table. What is vector table? Vector table consisting of a series of locations address. So that will be referred. The table will be referred, and in that table, what type of interrupt is being invoked, that will be identified, and from that the address will be located. From that address it jumps to that address location, that is called vector location. In that vector location we are supposed to write a routine, that is called ISR. ISR stands for interrupt service routine. So we have to write a code in that. Then after that, soon after servicing the interrupt, the last instruction we should introduce there is RETI, return from the interrupt. So when the compiler or assembler encounters that RETI instruction, immediately it jumps back to the main program and it resumes the main operation. So in this way you can understand the behavior of the interrupt. The moment when the interrupt is occurred, immediately it jumps to the vector table, refers the location, and jumps to that vector location where it consisting of a ISR code, and it will service the particular given code over there. At the last instruction, RETI instruction, it jumps back to the main program and it resumes the given operation, say logical operation. So here I have taken the snap of the LDA EDA board, where in your lab you can find this kit. This is a LDA EDA board 8051, where the toggle switch as well as the LED is already hardwired. It's connected already. So that means you should find where it is connected. So I have highlighted with the circle here where this is toggle switch, and it is internally hardwired to the INT0. Similarly, I am going to invoke, or I am going to trigger the LED P1.2, which is again hardwired to the microcontroller. So whenever I make a press of this switch, so this LED is going to show the status whether I am invoking the interrupt or not. So in this way you can try to understand the behavior of this. So the working of this is well illustrated here by using the statements. Let's try to understand one by one. First, in the microcontroller EDA board, already toggle switch hardwired to INT0, that is 12th pin of 8051. So where you can find this is already hardwired to the 12th pin. So that is shown over here. So the toggle switch is connected to the INT0, which is the 12th pin of the microcontroller. So that means the toggle switch INT0 it is connected to the INT0 of 8051. That's the first point. The second point, LED is hardwired to the P1.2. So this LED is mainly we are using to showcase the status of the interrupt, whether the interrupt is generated or not. So next, how it works. So I'm going to explain again the flow diagram, which is in a statement now. When toggle switch is pressed, which generates external interrupt INT0 and jumps to the vector location. That is this flow. When I press a switch, immediately it refers the location which interrupt been called, and it jumps to the vector location where ISR code is written. ISR, interrupt service code, is written in the vector location starting from the address 0003. You are going to understand it more detail by referring the vector table. So especially INT0 address is 0003. So because of that I am showing here 0003. In the ISR code will turn on LED as long as the toggle switch is pressed. So that means in the ISR we have written a code in such a fashion that till I press the toggle switch, the LED will be will be turned on. The moment I release that, so the LED will goes off and it comes back to the main program. Now let us try to understand the programming aspects, where a simple program is shown over here. And what is this program? How we can understand this program? We are going to generate the interrupt, and whenever the interrupt is invoked, then what happens? So here in this program you can find where this portion is your ISR. I have marked here, which is interrupt service routine. Okay, this particular program, a small piece of a program starting from the location 003 is your ISR, interrupt service routine. The last instruction of the ISR should be RETI, return from the interrupt. Okay, and here this is your main program. A single line code is written here, originating from the location 0300. You may ask me, why sir 0300? Why can't we start from 000? Just because we are going to use interrupt. So in the vector table you can find, so all these are all interrupts actually. Whenever a particular interrupt is invoked, it jumps to the respective location. This is called vector location. So this table is your interrupt vector table, and this is your vector location, where your interrupt vector table will be holding these locations. So immediately after referring to this location, it jumps to the respective location, and it serves the purpose for that. So accordingly, till 0023, some more locations will be occupied for the interrupt operation. So we are not going to utilize those locations. So try to utilize from 0100H, 100H, or say 300H would be convenient to write the main code. So that's why the main code is started from the location 0300H. And in the main program, what are we doing here? Let's try to understand from the main program itself, because after originating 00, we are jumping to the main program. That means it goes here. So, and I am moving 81 to the interrupt enable register. It's a 8-bit register where you can find the detail here. IE stands for interrupt enable register. I am moving 81. What type of data is, what it is going to do? All this information we can try to understand here. 81, where when I move to the IE interrupt enable register, so it is going to set a individual bits. What it does? So 81 is nothing but 1000, which is 8. 0001 is 1. So accordingly, EA, whenever I go for an interrupt operation, so keep it in your mind, this should be enabled, which is written over here. Enable all must be set to 1 in order for rest of the register to take effect. So that means if this is not enabled, then rest of the interrupt will not work. So accordingly, for your information, I am going to use only one interrupt, that too INT0. So in order to use external INT0, so I am making last bit 1, which is EXE0. EXE0 refers to IE of 0th bit, enables when I pass 1, which is a external interrupt 0, that is INT0. So accordingly, here, so the address of the INT0, you can refer here, external hardware INT0, the address of that is 003. That means After making enabling external INT 0, it is ready. This switch now it is monitored, okay, by using this statement. Whenever I press a switch, that it is going to jump to the interrupt vector table, and it is going to refer which type of interrupt been enabled and which type of interrupt is invoked. So accordingly 003 is invoked because it's INT 0. So immediately we are supposed to write a ISR code, what we are expecting in the ISR. So that code is also written here. So because the statement is like this, whenever interrupt is generated, we have to turn on the LED till I press a toggle switch. That's what we are expecting. So accordingly, in the location, starting from the location 003, I am initially clearing the P1.2. In the P1.2, I have connected a LED here. LED is connected. So that means in that port, I am clearing initially. Then small delay being introduced here. A delay program is written. It's a decimal number. 10 is a decimal number. That means in a hexadecimal it is a 0A. A very small delay being called here. Then after that I am setting port 1.2, which makes it is going to turn on the LED as long as I press a toggle switch. The moment I release the toggle switch, the last instruction will be RETI. So it jumps back to the main program. In a main program we are doing nothing. We are just monitoring the particular toggle switch. In this way, we can try to understand the behavior of the interfacing a simple toggle switch to the 8051. Thank you.